There is a specific kind of confidence that comes from being first. Not first to market in the startup sense, where first sometimes means you got there before the idea was ready. First in the way that a category is named after you before anyone else understood what the category was. Valvoline has that kind of first. The brand dates to 1866, when a physician named John Ellis, working with the properties of petroleum distillates, discovered that crude oil could be refined into a lubricant capable of protecting the steam-powered machinery of the industrial era from the friction and heat that wore it down. He built a product around that discovery, and what grew from that work became the oldest motor oil brand in American history. Not one of the oldest, the oldest. By the time gasoline-powered automobiles arrived and reshaped what a motor oil needed to do, Valvoline was already there. The institutional knowledge, the brand recognition, the distribution relationships built across generations of mechanics and fleet managers who knew the yellow jug by sight before they knew much about oil chemistry. And in that same historical moment, 1 year later and an ocean away, Alfred Nobel patented a compound he called Dynamite. Two products born in the same breath of history. One of them would define a market category for over a century. The other would arrive eventually in the form of synthetic motor oil chemistry, and the market Valvoline had spent that century building would absorb the blast. The Nobel analogy is not rhetorical. Dynamite is not a better version of gunpowder. Gunpowder can be improved. You can refine the mixture ratios, control the burn rate, improve the granule size. Dynamite operates on a different physical principle, releases energy through a different mechanism, at a scale no incremental improvement to gunpowder could match. When Mobil 1 brought polyalpha-olefin synthetic base oil chemistry to the American retail motor oil market in the 1970s, it did not improve on what Valvoline had spent a century building. It reclassified it. The category Valvoline had defined and dominated was no longer the top category. Synthetic base oil chemistry, built on manufactured molecular chains rather than refined petroleum fractions, moved the ceiling of what motor oil could achieve to a level that no refinery process applied to crude oil could reach through reformulation. You do not diffuse dynamite by making your fortifications thicker. The whole defensive posture has to change. Understanding the depth of what Mobil 1 disrupted requires understanding what Valvoline built before the disruption arrived. Through the first half of the 20th century, as the American automotive market expanded from a novelty into a mass consumer product, Valvoline was doing something more valuable than making a good oil. It was building the infrastructure through which motor oil decisions were made. Service stations, fleet accounts, the professional installer channel that formed the distribution backbone of the American automotive service industry. These relationships were not built on advertising spend. They were built on decades of consistent product supply, technical support, and the institutional familiarity that comes from being the brand that was there before the installer was trained, before the service station was built, before the car that needed oil existed. Valvoline's position in the performance and professional sectors reinforced the consumer perception of the brand over those decades. Endurance driving records, motorsport applications, and high-temperature industrial uses where conventional petroleum was being tested at its practical limits. These were not marketing claims applied retroactively. They were results earned in applications that did not forgive oil failures, and they became part of the brand's institutional credibility in a way that advertising alone cannot manufacture. By the middle of the 20th century, Valvoline's market position was not primarily a function of marketing investment. It was a function of institutional inertia at a scale that is difficult to dislodge from outside. Fleet managers who had specified Valvoline for 20 years did not reevaluate that decision quarterly. Service centers whose supply chains ran through Valvoline distribution did not rebuild those supply chains because a competitor published a datasheet. The brand held its position because the systems that distributed and specified it were built around it. And systems of that scale restructure slowly and only under sustained competitive pressure that the systems cannot absorb. This is what Mobil 1's synthetic chemistry had to overcome in addition to the technical argument. Not just making a better oil, making a better oil compelling enough to restructure decades of institutional purchasing behavior in a market that had never needed to question its default. Polyalpha-olefin base oil is made, not found. That distinction determines the ceiling of what the base stock chemistry can achieve. Petroleum base oil, regardless of how sophisticated the refinery process becomes, starts from crude oil, a mixture of thousands of organic hydrocarbon species with different molecular weights, different chain lengths, and different thermal stability profiles. The refinery process removes the species that perform worst, concentrates the species that perform best, and produces a base oil that reflects what the crude feedstock allowed. The ceiling is set by what was in the crude oil to begin with, and no amount of refinery engineering changes that constraint. Polyalpha-olefin chemistry has no crude oil ceiling. The manufacturing process begins with ethylene and builds alpha-olefin feedstocks from the ground up, then oligomerizes those feedstocks into base oil molecules with controlled molecular weight and uniform chain length. The result is a base oil where every molecule in the finished product is performing within a narrow, engineered specification window. No short-chain light fractions that elevate NOEC volatility and burn off through the positive crankcase ventilation system. No heavy molecular weight components that increase cold start viscosity beyond what the lubrication system needs. No batch-to-batch variation in molecular species distribution. What comes out of the polyalpha-olefin manufacturing process is what the chemists who designed it intended to produce, at tolerances that petroleum refining cannot approach. When Mobil 1 brought that base stock to the American retail motor oil market, the immediate technical argument was viscosity behavior, across the temperature extremes a running engine actually experiences. At cold start, temperatures where conventional petroleum oil was thick enough to temporarily starve the oil pump and delay full film establishment at bearing surfaces before damage could occur, polyalpha-olefin flowed. At sustained high operating temperatures where petroleum oil was approaching its oxidative stability limits and beginning to form varnish and deposit precursors on internal surfaces, polyalpha-olefin remained chemically stable. The viscosity index, the measure of how much an oil's viscosity changes across a temperature range, was higher for polyalpha-olefin than anything the conventional petroleum market could offer. And the used oil analysis results that came back from engines running on the new synthetic were consistently cleaner. Lower wear metals, lower sludge formation, lower acid accumulation than the same engines had produced on the best conventional petroleum available. That was the Dynamite, not the product claim, the test result. The numbers in the used oil analysis report that no refinement of conventional petroleum chemistry could match. The response Valvoline settled on is visible in the used oil analysis data on Valvoline Extended Protection Full Synthetic, and the number that defines that response most clearly is the molybdenum reading. 240 to 280 parts per million remaining after a standard drain interval. Mobil 1 Extended Performance returns 70 to 90 parts per million in the same analysis window. Valvoline is running 3 to 4 times the friction modifier concentration of its primary competitor in the premium, full synthetic category. That is not an accident of formulation. It is a deliberate engineering decision that reflects a precise understanding of where Valvoline needs to compete and what it needs to compensate for. Molybdenum dialkyl-dithiocarbamate functions at the boundary lubrication regime, the operating condition where the hydrodynamic oil film between moving surfaces has thinned to the point where asperity, contact between metal surfaces, becomes possible. At cam lobe and follower contact surfaces, at piston ring and cylinder wall interfaces, at wrist pin and connecting rod contact zones under high load, the oil film is thinnest and the friction energy loss is highest. Molybdenum disulfide deposits itself as a lamellar solid lubricant layer at those contact zones, providing a sacrificial surface between the metal faces that reduces friction and where, even when the pressurized oil film has become insufficient to fully separate the surfaces on its own. Mobil 1 Extended Performance carries 70 to 90 parts per million of molybdenum After a standard drain, because its polyalpha-olefin base stock maintains a more robust oil film across a wider range of operating conditions, reducing the severity and frequency of the boundary lubrication regime where molybdenum is doing its primary work. The base stock does part of the job, and the additive package does the rest. Valvoline loads molybdenum at 3 to 4 times Mobil 1's concentration, because it is asking that chemistry to carry more of the protection load at the contact zones where the base stock's film strength is not equivalent. Both approaches protect the engine. Both approaches work. The wear metal data at standard drain intervals confirms both approaches work. The question the used oil analysis is actually answering is which approach works at which drain interval and under which operating conditions. The kinematic viscosity data after a standard drain interval is where the base stock architecture difference shows up most directly. Mobil 1 extended performance comes back at 9.6 to 10.1 centistokes, measured at 100 degrees Celsius. Valvoline extended protection comes back at 9.4 to 9.8 centistokes. Both oils are 5W30. Both hold their grade classification through a standard drain interval without drifting out of specification. The difference is positional. Mobil 1 extended performance holds in the center of the 30-weight classification window after use, while Valvoline extended protection tracks toward the lower boundary of the 30-weight band under sustained mechanical and thermal stress. At a standard 5,000 to 7,500 mile drain, that positional difference within the 30-weight window does not represent a protection failure. Both oils are within specification. The trajectory matters more than the position at any single drain endpoint. An oil that is at the lower boundary of its grade at 7,500 miles is not within specification at 12,000 miles. Valvoline extended protection was not designed for 12,000-mile drain intervals, and the viscosity data evaluated at its intended interval tells the story of a formula that does what it was built to do. Fuel dilution tolerance is where the base stock creates a practical protection gap in modern turbocharged direct injection engines. Mobil 1 extended performance carries a high fuel dilution tolerance rating. Valvoline extended protection carries a moderate rating. Gasoline direct injection combustion produces fuel dilution events on virtually every cold start, as pressurized fuel injected into the cold combustion chamber reaches the cylinder wall before combustion temperatures stabilize, and liquid fuel washes past the piston rings into the crankcase. In a vehicle operating primarily on short urban trips, the crankcase never reaches the sustained temperature needed to fully volatilize accumulated fuel through the positive crankcase ventilation system. The oil is carrying a continuous fuel dilution load that depresses its effective viscosity below the nominal kinematic value the grade specifies. Polyalpha-olefin and alkylated naphthalene base stock resists this viscosity suppression more effectively than a Group 3 dominant base because the synthetic molecular structure has lower affinity for hydrocarbon fuel compounds under the conditions where fuel and oil are in contact in the crankcase. For a turbocharged direct injection engine in city driving conditions with frequent short cold starts, the fuel dilution tolerance gap is the most operationally relevant difference between these two oils. The total base number entering the crankcase fresh is the primary determinant of how long the oil can protect against acidic combustion byproducts before its neutralizing reserve is consumed. Mobil 1 extended performance enters at approximately 8.5 milligrams of potassium hydroxide per gram. Valvoline extended protection enters at approximately 7.8 milligrams of potassium hydroxide per gram. Every combustion cycle in a gasoline engine produces acidic species that enter the crankcase environment. Sulfur compounds in the fuel form sulfur dioxide during combustion, and a portion of that sulfur dioxide reacts with water vapor in the blow by gases to form sulfurous and sulfuric acid. Nitrogen from the combustion air forms nitrogen oxides at high combustion temperatures, and those nitrogen oxides combine with crankcase moisture to form nitrous and nitric acid compounds. The alkaline reserve in the motor oil, measured as total base number and carried primarily in the calcium and magnesium detergent package, neutralizes these acids through direct chemical reaction that consumes base chemistry while producing neutral salt compounds. Each neutralization reaction permanently depletes a fraction of the total base number reserve. After a standard drain of 5,000 to 7,500 miles, Mobil 1 Extended Performance retains 2.8 to 3.6 milligrams of potassium hydroxide per gram remaining. Valvoline Extended Protection retains 2.2 to 3.0 milligrams of potassium hydroxide per gram remaining. At standard drain intervals, both oils retain meaningful acid neutralizing reserve. The gap between them becomes structurally significant as the drain interval extends. At 10,000 miles, Mobil 1 Extended Performance retains a usable buffer. Valvoline Extended Protection is approaching the lower limit of protective reserve in average operating conditions. At 15,000 miles, Valvoline's acid neutralizing chemistry is exhausted. Mobil 1 Extended Performance is not. The 8.5 milligrams of potassium hydroxide per gram starting reserve was not a marketing specification. It is the arithmetic of average acid production rate across a modern gasoline engine. Multiplied by the 20,000-mile rated drain interval, the formula was engineered to support. The wear metal data at standard drain intervals reflects how the competing formulation strategies translate to actual protection at the contact surfaces. Iron comes back at 7 to 12 parts per million in Mobil 1 Extended Performance and 8 to 13 parts per million in Valvoline Extended Protection. Copper runs at 2 to 4 parts per million in Mobil 1 Extended Performance and 2 to 5 parts per million in Valvoline Extended Protection. Aluminum runs at 2 to 4 parts per million in both oils. Chromium and lead are at trace levels in both reports. The Mobil 1 Extended Performance edge on iron and copper is consistent with what the base stock architecture and fuel dilution tolerance advantage predict. A base oil that maintains a more robust hydrodynamic film across the full drain interval produces a thicker average film at bearing and cylinder wall contact surfaces, and a thicker average film produces lower average metal loss per unit of operating time. The per-interval difference in wear metal accumulation is not large enough at a standard drain interval to represent a meaningful protection failure by Valvoline Extended Protection. Accumulated across the service life of an engine that will see hundreds of thousands of miles and dozens of drain intervals, small per-interval differences in wear rate compound into differences in engine longevity that the single drain-used oil analysis snapshot cannot capture. The boron dispersancy data shows the other significant additive chemistry separation. Mobil 1 Extended Performance comes back at 120 to 160 parts per million of boron remaining after a standard drain. Valvoline Extended Protection comes back at 70 to 90 parts per million remaining. Boron dispersancy chemistry keeps combustion soot, fuel dilution residues, and acidic byproducts suspended in the oil solution rather than allowing them to agglomerate and deposit on piston ring grooves, camshaft bearing surfaces, and turbocharger oil passages where deposit buildup restricts flow and accelerates localized wear. Valvoline Extended Protection's lower boron reserve at the end of a standard drain is not a failure at that interval. The chemistry has been working throughout the drain, keeping deposits in suspension and delivering them to the filter. The risk condition is the driver who extends the drain past what the dispersancy reserve can support. 70 to 90 parts per million remaining at 7,500 miles approaches zero at 12,000 miles. At that point, combustion deposits that would have been held in suspension begin finding surfaces, and the bore scope at the next service records the outcome. Calcium and magnesium readings are close between the two oils. Calcium comes back at 1,000 to 1,200 parts per million in Mobil 1 Extended Performance and 1,100 to 1,300 parts per million in Valvoline Extended Protection. Magnesium runs at 650 to 800 parts per million in Mobil 1 Extended Performance and 600 to 800 parts per million in Valvoline Extended Protection. The calcium and magnesium detergent package handles combustion deposit suppression and low-speed pre-ignition suppression chemistry in modern turbocharged direct injection engines. Both formulas carry competitive detergent loading. Zinc dialkyldithiophosphate readings are close. Mobil 1 Extended Performance holds 750 to 850 parts per million zinc and 650 to 750 phosphorus. Valvoline Extended Protection holds 700 to 820 zinc and 600 to 720 phosphorus. a modest Mobil 1 extended performance edge on anti-wear chemistry that does not materially change the protection outcome at standard intervals. The competitive dynamics between these two brands play out on terrain. The used oil analysis does not map. Valvoline operates one of the largest company-owned quick lube service networks in North America. When a consumer drives into a Valvoline instant oil change location without specifying a product, the oil that enters the engine is Valvoline. That choice was not made at the shelf. It was made by the business model that built the service center, stocked the bay, and positioned the brand as the default at the point of service. That captive service moment is a distribution advantage no technical specification can replicate. Volume moves through that channel at a scale that exceeds what premium synthetic retail shelf placement generates because the service channel reaches consumers who have never looked at a used oil analysis and never will, and who make their oil decision based entirely on where they happen to stop their car. Mobil 1 has built its competitive position around the original equipment manufacturer specification channel. When an automaker engineers a factory-fill lubricant specification, the reference chemistry for that specification is built around the performance standards Mobil 1's formula helped establish. New vehicles arrive with oil in the crankcase from the assembly line, and the first oil change decision a new vehicle owner makes is measured against the factory baseline. The implicit endorsement of the original equipment manufacturer's production decision carries weight that no aftermarket advertising campaign can replicate. The buyer who follows factory recommendations without evaluation is buying Mobil 1 by default. 2 channels, 2 buyer archetypes, a market large enough for both to operate at scale without either erasing the other's position. The Dynamite Mobil 1 dropped into Valvoline's market in the 1970s has not destroyed the structure it hit. It has reshaped it into 2 parallel structures that coexist without resolving the competition between them. The extended drain economics are where the formulation difference creates a decision framework that rarely gets discussed in the product comparison context. Mobil 1 Extended Performance's rated drain by an interval of up to 20,000 miles is a genuine engineering specification. The polyalpha olefin and alkylated naphthalene base stock, the 8.5 milligrams of potassium hydroxide per gram initial total base number, and the high fuel dilution tolerance rating are all components of a formula engineered to remain protective across an interval that conventional wisdom in the American market treats as extreme. A consumer who actually runs Mobil 1 Extended Performance to its rated interval pays a lower cost per oil change than a consumer changing Valvoline Extended Protection at 5,000-mile intervals, even at a higher per quart shelf price. The economics of extended drain are favorable to the premium product when the drain interval is fully realized. The problem is that most American consumers do not run 20,000-mile drain intervals regardless of what the product specification supports. The default behavior for consumers who care enough to buy full synthetic is a 5,000 to 7,500-mile interval, shaped by quick lube recommendations, vehicle service reminder systems calibrated conservatively, and the residual cultural habit of frequent changes that formed during the era of conventional petroleum oil. A consumer changing Mobil 1 Extended Performance at 5,000 miles is paying the cost of a 20,000-mile drain interval engineering commitment and realizing approximately 1/4 of what it was designed to deliver. At that drain frequency, Valvoline Extended Protection is the better economic choice. The Dynamite only detonates at the intervals the formula was built to reach. Valvoline has been operating in the competitive environment Mobil 1 created for 50 years. What the brand built in response is not a concession. The 240 to 280 parts per million molybdenum load in Valvoline Extended Protection, the competitive total base number reserved for standard drain intervals, the quick lube network that moves product through a captive service channel at volumes the retail shelf cannot match, the institutional presence in the professional installer market that predates Mobil 1's existence by over a century. All of these are the architecture of a brand that understood exactly what it needed to answer and built a commercially viable answer to it at the price point where most motor oil decisions are actually made. The used oil analysis at a standard 5,000-mile drain interval tells the story of two oils that are closer than their formulation philosophies suggest. Every Mobil 1 extended performance edge on viscosity retention, fuel dilution tolerance, total base number reserve, boron dispersancy, and wear metal readings is real and measurable. None of them, at a standard drain interval, represents a protection failure by Valvoline extended protection. The gap opens as drain interval extends. The gap becomes structural above 10,000 miles, where Valvoline's reserve chemistry is approaching exhaustion, and Mobil 1 extended performance is still operating well within its rated window. At and below the standard extended interval, Valvoline's molybdenum strategy and competitive additive loading keep the protection numbers close enough that the price difference at the shelf is a legitimate reason to choose the yellow jug. Dynamite is only as consequential as the structure it hits. Valvoline's structure has held for 50 years after the blast. That is either an argument for the resilience of a brand that understood how to compete in the landscape Mobil 1 created, or evidence that the dynamite has been detonating in slow motion for 5 decades, and the used oil analysis is where you go to measure the yield.